Welcome back to Office Hours. This is question number 3 from homework D2. It's about balloon payment mortgages. Now, in class, we did look at mortgages and present value annuities to be able to calculate their payments, but we never did a balloon payment mortgage. It's not that much different, right? For example, in a regular balloon payment or in a regular mortgage, you might calculate the payment is $1,500 and you make that same payment over every month for the next 30 years. And maybe the last payment needs to be a little bit different. We saw that in our amortization tables before. The rounding often makes the last payment off by a few cents or sometimes even a few dollars if the loan is big enough. But in a balloon payment, the quote unquote last payment is actually much earlier. And what you see in the problem here, if you read the paragraph, is that this is a 20 due in 6 balloon mortgage. What that means is that I'm going to calculate the monthly payment as if the loan were taking 20 years to pay off, but I'm actually going to call it done after 6 years. And that big giant balance that's left after 6 years will be a big giant balloon payment when we're done. Okay, so let's take a look at this problem. We have a $260,000 20 due in 6 balloon mortgage with a 6% down payment. So let's see, I've got 260,000 and a 6% down payment means that I'm financing 94% of it, right? That's 100% minus the 6% down payment. So let me calculate $260,000 times 94% or 0.94. I'll go to my Desmos calculator to help me here. 260,000 times 0.94 is $244,400. That is the initial balance of this loan. $244,400. Essentially, that is the present value of this annuity. The number of periods used to calculate the payment is, let's see, I'm calculating the payment as if it were a 20-year mortgage. So 20 years times 12 monthly payments is 240 in. That would be the in value in my calculation. The monthly payment on the mortgage, now I have to actually bring out the formula. So to do this correctly, I need to figure out what's the PV, I know that, what's the N, and what's the I value. See, the I value is, the interest rate is 3.75% compounded monthly. So the I value, it doesn't give me an answer box for that, would be 0.375. That's 3.75% as a decimal over 12 because it is a monthly calculation. So I have my PV, I have my N, I have my I. Let's go to the formula now. Normally the formula for present value looks like this. PV equals PMT times a fraction. But since I'm solving for the PMT here, I'm actually going to use the upside down version of this fraction. That's what happens when you take a fraction from one side of an equation and basically move it to the other. So let me give you the upside down version of this formula's fraction. PV times I divided by 1 minus 1 plus I to the negative n power. Okay. So I know N, and I know PV. I can type all of those things in to my calculator and get an answer for that. Let me go to the Desmos calculator to help me here. So it's PV, 244,400 times fraction. You could put parentheses around this fraction. You could not. It's kind of nice to do it just because it's maybe a little bit neater. But you see how I've kind of put the skeleton of this fraction in the calculator first to make it easier for me to type this in. I know my I is 0.0375 over 12. And I know the bottom of the fraction is 1 minus 1 plus I. It's a lot to type in, right? 1 plus I raised to the negative 240 power, or the exponent is negative 240. So that gives me a payment of 1449 and 02 cents if I rounded. 1449.02. That is the monthly payment. But what we'll find is that after 7 years, we are nowhere near paying off this mortgage, or excuse me, after 6 years, which is when the balloon payment is due. After 6 years, we're going to have a lot to pay in that very last payment. So the balloon payment is due after 6 years. 12 times 6 is 72. So after payment number 72, then the balloon payment comes due. And after I pay the balloon payment, the loan balance is 0. So knowing all of those things, let's take that down to the amortization table now. I'll copy some of the things from up above. Notice that part 2 of the question shouldn't show up until you've answered part 1 correctly. So there, the ending balance for year 0 is in the beginning should show 244,400. That is correct. But it wouldn't show you that number beforehand. We calculated that our payment was 144902. And that payment will be the same every year or every month until the very last one. This last payment here, I don't know what it is yet because that payment is set to make the ending balance be 0 here. So I'm going to hold off on filling that one in. I know that my balance in year 1 is the same as the ending balance from year 0. Now I need to actually calculate the interest and the principal. Let me go back to my Desmos calculator and do those calculations. Let's see if I can make this a little bit smaller so I could see everything happening at one time. So now I know that if my balance is 244,400 and my interest is 0.0375 over 12, that tells me that in that first payment, my interest is $763.75. 763.75. Now that's just the interest part of the payment. To figure out the principal part of the payment, I take the total payment and I subtract the interest part, 763.75, which tells me the principal part is $685.27. These two numbers should add up together to equal the payment number. So it's a little bit redundant to see them both in the table. We don't need them both, but that's okay. To find the ending balance, let me take the beginning balance minus the payment. Minus the payment plus the interest. So the beginning balance, 244,400 minus the payment, 144902, plus the interest, 763.75. That tells me that after the first payment, oh, sorry, I need to lock this picture into the background here. I've got set pictures background. There we go. The balance is now 243,714 and 73 cents. Now you can do this with Excel. Essentially, we're just asking Excel to do our additions and subtractions for us. The video will show you how to do that. I'm doing it manually, not because I think you have to do it manually or not because I think it's super important, but going through at least a few of these steps can help you remember why we're doing what we're doing. That balance comes down to the next row, 243,714, 73 cents. I need to calculate the interest again. I would normally be able to go to the next row in and of itself, 243,714, 73 cents times my I, which is 0.375 over 12. I apologize that this looks a little bit zoomed out. Let me see if I can zoom out on this. There we go. It's a little bit smaller, but you can at least see everything I've typed in. The interest amount for payment number 2 is a little bit less, as it should be, $7.61, and I would round that to 61 cents. Because we paid off a little bit of the balance, then the interest will be a little bit smaller too. Now, in payment number 2, the balance is 243,714 and 73 cents minus the payment 144,902 plus the interest 76161. That is 243,027. And 32 cents. Oops, looks like I forgot to calculate the principal for the second payment. Sorry about that. 144,902 minus 76161. That's the total payment minus the interest amount, which is 687.41. And as we see, that should be a little bit higher because now we're paying off a little bit more of the principal every time. Now, the full amortization table would show every single payment, all 72 of them. Luckily for us, we don't need to show all 72 rows of this table. We can skip down to payment number 71 and 72 to show you that, well, we got it from here, really. After, let's see, payment number 71, the beginning balance is 190,873. 190,873 and 17 cents times my I, 0.0375 over 12. That means the interest part of the payment is 59648 if I round it. Getting a bit smaller now, but still not that small. 144,902 minus 59648. The principal part is 852.54. Which means the final balance is 190,873.17 minus the payment plus the interest 190,020.63. Are your eyes swimming in numbers yet? Again, each one of the calculations that I'm doing here, you can see most of them are just additions and subtractions. Every now and again, I throw in a multiplication when I'm doing the interest calculation, but keeping this organized is the hard part. For the final row, I now have my final beginning balance, 190,020,63. I'm going to calculate my final interest amount times 0.0375 over 12. So the final interest is $593.81. Or excuse me, that's the interest amount, $593.81. Final payment, I'm not so sure about. Essentially, I know that my beginning balance plus my interest minus the payment is equal to 0. So if I added 190,020,63, that's the balance, plus the interest, 573.81. I need to pay all of this off as part of the payment. That is the balloon payment. Everything that's left, 190,594.44. I apologize that my handwriting is a little bit too big to fit in these small boxes, but you can see the numbers on the right side of my screen. And that means the ending balance is 0, just like I wanted. So just to make sure I know what the principal part is, I'll take the final payment, 190,594.44 minus 593.81. And so it shouldn't surprise you that this number, 190,000.63, is the same as what we had before. Should be the same. Did I type this in wrong? 593.81. 190,020.63. Oh, sorry. You can see my error right here. That was supposed to be 593.81. So that should be 190,614. 44. 190,614.44. And when I take my balance now, it's 190,020, and I have one. I'll copy that here. $190,614.44 minus 593.81. I get the same number that I had in my beginning balance here in payment number 72. That's not a coincidence because I have to pay off the entire beginning balance plus whatever interest that I get during that final month. So that's why these two numbers should be the same, 190,020.63. And I'll maximize this so you can see all the numbers in my table. I may have made a mistake here, right? I don't have the answer button to click. I know you see the answer keys on my screen, but because I took a screenshot, I can't actually fold them open. I may have made a mistake here, right? But that's okay, right? I'm not expecting you all to be adding machines when it comes to solving problems like this. I'm expecting you to know what we're talking about. And in this mortgage, just to refresh what we were talking about, we calculated the payment on this mortgage as if it were a 20-year mortgage. That's why we got a payment amount of 144902. But then when we went to the amortization table, we did something special, right? Instead of going all the way down to 240 payments, which is what normally an amortization table would do, we stopped after 72 payments. And we said, after 72 payments, just shut it down, just pay it off. That's what we call the balloon payment. And so the balloon payment was 190,614,44, the balloon payment of the mortgage.